Hello and good afternoon. I'm going to walk us through some AutoCAD shop drawing training today. Little by little, that's what they say. Okay, so let me step back a little bit because obviously you're not understanding what you're looking at here. These are some CAD drawings that I've been in the process of reconstructing here for the last few minutes. So the shop drawings that we're looking at today, as you know in previous videos, I've explained to you that it's not always easy, cut and dry. Essentially, reconstructing, we are reconstructing some drawings that the architect has kind of, sort of already provided us, but we are reconstructing them in a manner that our facility will understand them as shop drawings and or fabrication drawings. And we're also going to supply these to the architect so that he can provide us with his blessing to proceed. So essentially, what we're trying to provide some drawings for is this right here. Okay, so what is this? Probably is your question. Well, this is some kind of an outdoor patio. As you can see, patio paver plan. They provided like a plan for the pavers. And this is a wall that goes around this patio. And the detail is kind of vague, but if you see here, if you zoom in, it's very easy to miss. You'll see the detail there, SP-20 detail 8. It's giving us a wall cut view. Okay, so it's actually telling us it's on the same page, SP-200 detail 8. So if we zoom into this detail, this gives us an example of what that wall will look like. So we have two things that we need to construct here. We need to provide the architect and our shop fabrication facility an idea of these items here. We're going to manufacture this cast stone banding, this water table on the inside and outside. And we also have to fabricate this top, this cast stone. They're also calling it a water table, but it's a coping. Anything that goes on top of a wall that runs horizontal is a coping. Okay, so we need to provide drawings for both items. So what I've done is they give us a pretty good idea of what the measurements of this wall are. And I've already begun to construct the wall based on measurements given. We also know the width of the wall, where they give us the cut, is 1'4". Okay, at this part of the wall, it's 1'4". So we are missing a detail or a cut through these pilasters, these columns, and just based on experience, I'm going to assume, we have a measurement here. We know they're 2 foot. And if we scale it, we can also, with our measurement tool, we can also come to the conclusion that they're 2 foot by 2 foot. But just to be safe, I scoured the plans and I was able to locate another detail in the footing foundation plan. And those are on S4.2. S4.2. And yes, I had to go sheet by sheet because I don't remember seeing anything in the plans that actually pointed me to these sheets. However, these details were available to us just by looking through the sheets for the structurals. And what this will tell us is that this is the wall detail, and it is 1'4" wide. We've already figured that part out, but based on the architectural cut. But here's the missing detail that we didn't even have. This is the pilaster detail. So yes, it is 2 foot. It's 2 foot by 2 foot. Okay, so let's go back to the architectural cut. And we know we have two different profiles. We have the water table profile and we have this coping profile. And there's two different sizes. There's going to be the 1'4", the wall that is 1'4", and then these pilasters that are 2 foot by 2 foot. The only thing that we weren't 100% positive on just by looking at the overhead view is whether or not the pilasters are the same height as the wall or are they taller than the wall. So we don't really know that at this particular point in time, because even on the structural sheets it's just a cut. All right, so you see the cut. They're not providing us with the height. And looking at the detail of the wall, it does give us a height, but it's not giving us, obviously, as we already came to the conclusion, we don't have a cut through the column. So we don't know if these columns are actually taller than the rest of the wall. Now, it would make sense if we go to the profiles. It makes sense that it all runs at the same height because it's the same profile overall, give or take. Hold on a minute, sorry. Okay, apologize about that phone call. Anyways, so we're gonna assume that it all travels together horizontally on the same plane, same elevation. Considering that the profile is the same, it has a chamfer, I'm just assuming that. Because if we go back and we look at the elevations of this building, there are no elevations that show us, there are no elevations that I know of that show us this outdoor patio area. So based on that, we're just going to assume that it's all in the same elevation. Okay. So going back to our drawings, these are the dimensions that they want us to follow. A little strange, considering the pilaster is 24 by 24. They want this to be 2.25 foot by 2.25 foot. I think that's okay. I mean, I'm not the architect, so the architect needs to know what he's doing. And this is the coping in the middle. That's what doesn't make any sense to me. Why overhang it 1/4 of an inch on the column caps and only 3/8 of an inch? And why change the dimension at all? It makes it more difficult to draw. So I'm going to make a slight change just because it makes it easier to draw. And I'm going to overhang. I'm going to make this dimension the constant, 3/8 of an inch. Because in all reality, it's not that much different from 1/4. Okay. So let's go back to AutoCAD. Now, as you can see, I've already reconstructed most of the wall and the pilasters using the dimensions that we were able to locate in our estimating software using these dimensions. Okay. Obviously, they have some weird angles here where it meets the building. I didn't bother drawing those weird angles. I just followed it all the way off and squared it off, and they can make the field cuts in the field. It's not necessary for us to draw that. So the first thing we want to do is we want to finish polishing this setup. We want to finish polishing this layout up, okay? And the way we do that, or at least the way I'm going to do it, is go ahead and just polish it up, make it kind of look like this. We have all our dimensions, but here we go. because it's all continuous and these pilasters are not taller than the wall, we're going to delete these lines. Okay, if this pilaster was taller than the wall, then the only thing that we would be doing here is deleting these lines. And then we would draw that cap on top of this space, basically that chamfer that you saw. But because we want to indicate that it all travels at the same height, we're going to delete these lines as well. Okay, all travels on the same level. I just want to make sure that this is all centered. Pretty sure it is. That was one of my cleanup processes. Yeah, that's a centered line. All of our lines look to be, no, see, we're slightly off center here. There was an issue with my original drawing for some reason, and it was slightly shifted and off center. My pilasters were. So I had to go back and recenter all my pilasters. I think I missed these pilasters. So to recenter these pilasters, it's kind of a tedious chore. And they're off just by a little bit. It's not much, but it's enough to cause issues later on down the road. So don't ever take shortcuts. If something's not right, make sure you fix it, even if it's a little bit. You see, as you zoom in, you'll see that these center lines, oh, they're center. You know, that's close enough. Well, as you zoom in, you'll see that it's not. And if you were to put a dimension line on that, it's a 1/16 of an inch. You would think, oh, that's nothing. But unfortunately, with cast stone and fabrication, a 1/16 of an inch is enough to screw everything up. Sorry about that. So, you know, going back and recentering these columns are pretty necessary to make sure that everything lays out properly later on. Looks like these were on the opposite side of it, so it was kind of screwed up, but it's always good to just fix them, and that way later on you don't have to worry about it. This one, yep, this one's already, oh no, it's off just by a little bit. You would think that that's how much it was off, but it's enough to mess stuff up later. Especially if you're trying to fill and use the fill tool. If it's off and there's an itty bitty gap in between these two lines, then they're never going to line up and your measurements are going to be weird. Yeah, it's just best to get it right the first time. Alright, so let's go ahead and continue with our trim tool. Alright. Okay, back to work. So as I was saying, this is just, you know, the cleanup work. So as you can see, it looks like we're progressing a little bit better here. I believe I've already cleaned this, moved it where it needed to be moved. Looks like we're off center for some reason here. So I think this was a box that I needed to fix. So we're just going to draw a new box because of what happened here. We're not sure. When you zoom in on that, you can see that we're off kilter. And I can always pull that out and fix it. But we are off center as well. So, I mean, there's all kinds of measurements we need to be sure that are laying out properly. And apparently, this is all whack. Separate there, it's not separate here. Sometimes it's better just to draw a new box. All right. Now this is one that I had to pull a scaled measurement. There wasn't an exact measure on it. 6'10" 5/8". So as you can see, we're already a little messed up on the measurement. So this wall is supposed to be, see, it's messed up. So this wall is supposed to be, let's go ahead and draw. It's supposed to be 10'6" 5/8" by 1'4". Oh, I think I messed up. No, here we go. All right. No, I messed up. All right, let's try it again. Repeat rectangle. Dimensions. Let's say 10 foot, 6 inches, and 5/8 by 1'4". All right, there we have our wall. Did I get that right? Oh, no, 6'10" 5/8". I apologize, my brain is not where it needs to be at today, but regardless, we can just reduce this. By 4 foot. 6 foot. Wow. Okay. 6'10" 5/8". Here we go again, stretching the wall out. There we go. So now we have a wall that's 6'10" 5/8" by 1'4", which is what this wall should have been right here in this section. That's the wall. Our obviously what we're drawing is straight. This is, you know, they're providing us with an angled layout, the way it lays out up against the building, but we're not going to provide drawings that way. So this is what we're reconstructing right here. All right, so now we got the proper wall. We can go ahead and delete this wall that is no good and broken. Looks like we also have a line here that we need to get rid of. Okay. All right. Now we can take this wall, copy or remove it, make sure we're selecting on the snap line where it tells us that our center is at, or midpoint, and then we're going to move it to the midpoint on the column. All right, so now we have the proper wall. It is properly centered. And now we can move on to this little piece right here, which not sure why they have it laid out like that, but as you can tell, even on the original drawing, that's the way it's laid out. It's not going to look very good in the field, but you know, hey, it is what it is. So let's just go ahead and draw a square. I'm gonna delete. Actually, you know what? Let's just undo that. There's absolutely no way for us to tell what this is other than scaling it, which is probably a bad way to do it, but there's no other way to do it. Let's just call it 6 inches, and then obviously the width of the wall. Okay, let's draw a square. 6 inches by 1'4". Let's go ahead and delete that. Let's go ahead and move that into position, snapping it to the center lines. Now we can go ahead and trim this away, and there you have it. All right, we can go ahead and delete that. All right, so now we have an accurate representation of what they provided for us here. Oops, sorry. In the plans, okay? An overhead view. Now that we've cleaned it up, we're gonna go ahead, I had made a copy without changing, but now we've got a good clean copy. Everything is centered and squared. All of our lines look good. All of our measurements are good. I'm gonna go ahead and copy this because we are going to require to use it twice, and I'll explain. Remember, in our detail, we have to provide details not only for this coping, but also the water table, okay? When we zoom in on this water table, we can get the idea of how it lays out. You can see this chamfer here basically starts, it's going to overhang the measurement of this chamfer, okay? So the wall is 1'4", but we have a small overhang where this water table is going to overhang it, okay? So what we've drawn is the wall. That's what we've drawn so far. We've done nothing with the cast stone yet. That's what we're going to do now. So the architect was kind enough to provide us with a bunch of details on what he wanted the cast stone to look like, for the most part. This is the water table that we were supposed to be using on the wall that we're currently drawing. So we can see that it's a 3/4 of an inch chamfer, 3 5/8, 5 5/8. So all these measurements are representing what we need. So I've already reconstructed this profile in AutoCAD. Okay. So this chamfer is a 3/4 by 3/4 chamfer. These measurements don't really matter. The rest of these measurements don't really matter, not right now. So now that we're looking at this as in an overhead view, the easiest way to do what I'm about to do is just to select everything, use our modify tool, and join it, and join everything, okay? Now, you could have typed the command and done the same thing. If you know how to use AutoCAD and you like commands, by all means, use commands. So what that did, oh great, see, now we have a problem. We have some lines that aren't joining properly because they're not meeting properly. That was one of the things that I said we need to be careful about because, all right, so I'll fix that one. Looks like we have, so I use the fillet tool on lines that don't want to merge. We see everything merged until here, so there's a broken line somewhere. It's not merging properly because it's broken. I use the fillet tool, select the line, the last line that did merge, and then select the line that I want it to merge to. And as you can see, it fixes it. Fillet, bam. Yep, there we go. So it looks like that is fixed. Perfect. That is good. All right, so now that we've merged this all into a continuous line, essentially if you select one line, it selects them all, okay, which is what we wanted. So that water table overhangs the brick on that detail by 3/4 of an inch, okay. Go back to that detail. All right. It overhangs the brick for what this chamfer measures. And it's on both sides. That's the reason why we merged this, because it's easier. As a matter of fact, now that we've merged that, let's just delete that because we made changes and copy this. Now we don't have to go through the merge again. Okay, so we will use our offset tool. I'm going to type in the command 0.75, the measurement, that's 3/4 of an inch. I'm going to click outside. Oops, sorry, let me show that to you again. So we're going to click on the offset tool, or you can type in offset offset, okay, enter. Specify the distance. Well, it's going to be 3/4 of an inch or 0.75. Remember, these lines, what we've drawn here is the brick wall, okay? So looking at that detail, we know that we have to go outside the brick wall to represent this line of the cast stone, okay? On both sides. And that's what we're trying to represent. That's what we're trying to achieve here. So we pulled out our tools, our offset, enter, 3/4 of an inch. We're going to click on the main line and we're going to drag it out and then left click to set it. All that stuff that we did previously, joining the lines, making it one continuous solid item, etc., just saved us a ton of time. Because by doing what we just did, we just offset the main wall by 3/4 of an inch on the inside and the outside at the same time, all the way around. Okay. So now what we're seeing here is that 3/4 inch lip that represents the outside edge of the cast stone. Okay, that's the outside lip of the cast stone. This is would still be the brick, okay, technically. So let's go back to the detail. All right, looks like the cast stone is going to run with the brick and it's going to stop at the brick, but that's fine. But we've already reconstructed the measurements in AutoCAD, so we can look at the measurements that we've reconstructed here. It's 3/4 of an inch. That's the measurement that we just drew. 3 5/8. So it's beyond this 3/4 inch chamfer. It goes back 3 5/8. So that's the next measurement that we want to draw. I'm going to zoom in here. Offset. 3 5/8. I'm sorry, I have a terrible memory. 3 5/8. All right. Offset. 3 5/8. Okay. You can also type that in decimals, whatever you want to do. Enter. Now, we know that this is the outside edge, but this is where the 3 5/8 inch dimension starts. It's from the edge, right? Let's, without changing our tool, it's the 3 5/8 starts from the edge of the 3/4 inch chamfer. So essentially right here. So we're going to click on that line and we're going to drag it in. You see how the lines follow you all the way around? Isn't that amazing? All right. So we're going to drag it to the inside and left click to set that line. Now use your escape button. All right. So what we've done here is nothing short of a miracle. Modern technology here for people who don't know AutoCAD and don't know how to draw. I'm still, by many people's opinions, still very novice in the program. I've taught myself. Everything that I know and everything, my drawing style and the way I reproduce drawings is all self-taught. Never been to school. So, are there better ways to do it? There probably most definitely is. Essentially, you're never done learning. So never think that you are. Okay. So now what we're looking at here is an accurate representation of this profile. We are looking at this profile from the top down. So we are looking at it. Let's see. Sketch. So we are looking at this water table from the top down. And to verify that, it should measure 4 3/8. 3 5/8 here, 3 5/8 here, and then this lip should be 3/4 of an inch. So let's verify that. Yeah, 3/4 inch lip. Yeah, 3 5/8 inch. Wow, pretty good. All right, so this is the water table that goes all the way around this thing, front, back, sides, the whole 9 yards. That is the water table, okay? All right, my apologies, I had to take a quick break there. Okay, so let's go ahead and complete this one as well. This little side wall. And same way, 3/4 of an inch to the outside. Three 5/8 to the inside. And there you have it. Okay, so this is the water table. All right, so what we're going to do now is we're going to go ahead and add in all the joints and break it out with measurements. Let's go ahead and move this off to the side a little bit. All right, so the way we do this, or the way I'm going to do this, unfortunately, I'll tell you what. The way you break out water table and coping and things like that can get really complicated really fast. Really what it boils down to is personal preference on how it looks, what you think is best as a designer, because, I mean, let's face it, you're also kind of contributing to the design of the building. Now, if there's nothing indicated already on the plans that we don't have to follow, you know, if there's something on the plans indicated, you know, specific measurements, et cetera, layouts, then typically speaking, we have to follow that information. But otherwise, it's pretty much free reign on what the design is going to look like. We just need to make sure that it looks good. My apologies, I had to answer a phone call. Anyways, trying to remember exactly where I was in the video. So basically what we need to do now is, now that we've reconstructed the basics, we've reconstructed, or we've constructed this water table. But now what we need to do is we need to add more details as to the lengths that we're going to be fabricating these pieces in, the layout to assist the people on the job site on how it's supposed to be installed. And I remember I was talking about design. Obviously, if we go back to the set of plans and we're looking at the set of plans here, even if I turn off all of the lines that I'm showing here on this page, just turn off all this stuff, there's not really a lot of detail here showing us or telling us where they want the joints to be, other than the dimensions that they gave us for the pavers. Everything else about this wall, you know, was scaled based on dimensions that they provided here, and everywhere else. So in reference to design, it's really kind of up to us to provide them with what's possible and what's not in this specific scenario. So let's go back to our AutoCAD drawing. And what I mean by that is, you know, this is the piece that we're going to be fabricating from a cut view perspective. This is what we're going to be fabricating from an above view perspective, looking at it downwards. Now, obviously, we can't make this in one continuous long piece like we show it here. So we're going to have to divide this up into the pieces that we need it. And logically, the first place to start is at the pilaster intersections. Okay, these are going to be you know, 45s and corners and things of the such. So the best thing to do is to determine a size that needs to be fabricated. Typically, for a piece of stone like this, we don't really want to make them any longer than 3 feet, and 3 feet's really kind of pushing it. So just, that's actually something you need to write down for future reference. So what I would do in this particular instance, first of all, it looks like I brought the water table around. When we go back to the set of plans, it's going to die into the building here. Same thing here. So that's not really a true representation of what's going to happen on the actual building itself. So we'll correct that. We'll start by correcting it here. The way we'll do that, we'll verify the measurement 6'5" and 5'8" from the brick, 6'5" and 5'8". Okay, 6'5". So best way to do that is to just draw a line. Oops, sorry. Turn off our snap. Use the trim tool. Get rid of that. All right, that's where it's going to die into the building, more or less. We'll take the measurement again. 6'5". Stretch that to 5'8", and there we have our measurement, 6'5" and 5'8". And it's dying into the building. Okay. Well, this is also going to go away. I apologize. And this is going to be extended. There you have it. So the water table is going to come all the way. It's going to die into the building. Okay, so next thing's next. If we were to take these and draw this at a maximum of 3 foot, how is this going to lay out in between the columns? Are we just going to manufacture one size and let the mason do the cutting on the job site? Basically, we need to figure out the best layout possible. So it looks like it's going to be unique in these areas. These areas look to be the same, and then these are all the same with the exception of that. So, all right, so unfortunately, because this all has even dimensions and even spaces between evenly placed columns, my personal opinion is that we would not get away with fabricating one size and just placing them as we see fit, because then we're going to end up with small ending pieces, and my personal opinion is that it might look trashy. And to give you an example of that is, let's go ahead and do this. This is an inside corner. This would also be an inside corner. So let's say, what is this piece? This is 4 3/8. Okay. So 4 3/8. I like to use my array tool, path array. Grab that line that I just drew. Now, to use this tool properly, you're going to have to explode this whole assembly. And to do that, use our explode tool. Select anything, because it's all going to select the same thing anyways. Right click. Now, what did we just do? We just separated all of the lines that we had clumped together. Okay. All right. Actually, yeah, that's fine. Okay. So I drew a line here, the size of the water table. I'm gonna go ahead and use my array tool, selecting the long line from corner to corner actually. So let me go ahead and put another line there indicating that that's a corner. All right, so these are inside corners. They're going to cut those in the field. But what I mean by it's going to look trashy if we make one size and just let them go to town. If we were to make a specific size, let's say like what I just did now, those pieces would be 2'3", give or take. And they would look nice because they're flowing, they're all the same dimension. There's nothing shorter, you know, there's not a short piece and then a long piece. It just looks more aesthetically pleasing to the eye. Whereas if we were to measure these pieces, for instance, and we were to say, okay, I'm going to make all these pieces 24 inches. What happens is what you just see is what you see here now, is that you start out looking good, but then at the end, you're left with one short piece. And in my personal opinion, I think that looks bad, to be honest with you. Some architects would disagree. Some architects would say, you know what? I don't care. If that piece was dying into the end of the building, it wouldn't be as dramatic of an effect, and it would be acceptable. So if this small piece, if we did the same thing on this side, and we were left with a small piece over here, I wouldn't find it so objectionable because it's more acceptable because it's actually the end of the building. Whereas this is more out in the open. So in my opinion, it's more of an eyesore, to be honest with you. I don't know, that's just my opinion. But it's less acceptable from an architectural stand, or from an architectural stand view, or point of view, sorry. It's less acceptable to do something like this. But it just depends. It depends on the architect too. Some architects just don't care. Some architects will be like, yeah, I mean, it is what it is. It's a stone. What do you want? I mean, they're not picky. But then you have some architects that are. They're very picky. So let's proceed with doing the layout. All right, so I'm back. Now, after a little bit more analyzing our drawings and verifying all of our measurements to make sure everything was correct, I've also laid down some more lines and measurements, and I've decided that we're going to go ahead and proceed, at least initially, we're going to go ahead and proceed with one standard size. We're going to see how that plays out. Now, if I don't like the way it looks as we get halfway through, we'll see. These areas here look pretty good with a standard size of 30 inches. As you can see right here, we're not left with too small of a piece, which can definitely be ugly if we're left over with too small of a piece, for sure. But as you can tell, the measurements are relatively the same in these areas here, but then they start to get a little bit bigger here. So the same measurement of 30 inches will most likely work here because it's all the same dimension. I'm a little concerned with these areas here because they're a little bigger, but let's see how it plays out. So another thing that I've discovered, adding lines for piece sizes, is that because of the dimensions of the water table itself and the way it lays out on the columns, we're going to have to make special corner pieces for these columns. It's unfortunate because it's an extra mold, but there's really no way to get around it because you can't take a standard corner piece because of the size of the column. A standard corner piece would be basically a straight line. A standard corner piece, it's hard to get an idea what a standard corner piece would look like, but a standard corner would be something like this, but because it's bumped so far out, you can't install a standard piece here and then have the other one butt into it. It would be, in this particular situation, it would be very difficult because the standard piece, let me go ahead and make an example here. So a standard corner piece, the way I would draw it, would be like this. But because this piece doesn't come all the way forward, well, I take it back. It might be possible to cut this in the field. A standard corner piece would be manufactured like this. No, there would be no way to make it in the field because there would be a gap here in between the other one. Even if we were to 45 this piece, there would still be a missing chunk back here. And they'd have to shave off this nose, and then there would be a missing. It could be possible, but it's not really the right way to do it. The right way to do it is to just fabricate this corner, rather make this a fabricated unit. And why not, right? It's going to look better in the long run. The client's going to be happier. Sometimes it's just what we have to do. So let's go ahead and continue. I'm not going to put any joint lines in these columns because this is a relatively small piece. It's 2'1½". There's no reason to bust it up into two separate pieces. We can manufacture this as one unit, indicated by the joint lines you see here. So this will be one unit fabricated. We'll have two molds, actually one mold. One mold will work for both sides. It's just rotated around and used on the other side. Obviously, when you get into this situation, that's going to be a whole host of special molds just because of the corner condition. But one mold will work on all of these column conditions, both front and back. So that's good. Let's continue with breaking these lines out. 4 3/8. Okay, so let's go ahead and draw in our corner condition. All right, let's go ahead and add our line. 4 3/8. That's the line that we're going to grab and use our array tool with. Array. Click that line we just added. Measure. 30 inches. Not bad. We're not left over with some super small piece over here, so I'm good with that. Let's add our corner line. I'm going to go ahead and add our corner line here as well. Okay. Now, and we can actually even go farther and make some adjustments here. That's 30 inches. What would happen if we did 28 inches? That would actually even look even better. So that's 2'4". Let's adjust these to 2'4". The standard piece of 2'4". Let's go ahead and add our line in here. 4 3/8. Array tool. Grab that line. Measure. 28 inches. I like that, because we're not left with a small piece. We're left with a piece that we're going to have to cut at 24 inches, 24 3/4, but it's not far off from the standard size piece that we're making. And it's not an eyesore. You're not really noticing this really small, ugly piece left over. So I think in this situation, 2'4" is a good size to use for a standard runner piece. Okay, essentially we're going to do the same thing. We're just going to flip-flop that. I'll show you how to mirror those images here in just a moment. Let's work on this corner column. So yeah, this corner column. So this is going to be a fabricated unit. We're going to add some little corner lines in here to help our people understand that this is a fabricated corner. Yeah, so this is going to be a special piece, as you can see, with an L, a fabricated L on one end, but squared off on the other. And there might be a chance that the standard piece would work. Let's see what would happen if we were to take the standard piece yeah, it'll work on one side, but because it's been fabricated on the other side, it falls short. You see where it falls short on this corner here. That's what I was telling you earlier about that, the way it's made. Unfortunately, if I was to take this, cut this off and try to use it here, it wouldn't work because this line doesn't follow through. It falls short. It falls short approximately 3/8 of an inch to qualify as a standard piece. Okay, so this would be a fabricated piece. This would be a fabricated piece. Unfortunately, this would be a fabricated piece, this wacky, crazy thing here. Okay, so for the most part, the corner column's already done the way it needs to be fabricated. So let's go ahead and proceed with placing more lines. Let's draw our line 4 3/8. Oops. Let's go ahead and grab our array tool and select the long line. Looks like something's wrong here. What's going on here? I don't know. Guess I didn't execute the tool properly. Let's add our column line in, because sometimes it can get tricky. I like to add column lines in ahead of time. Kind of tricks my brain into doing what I need to be doing here. Okay. Let's try to grab that line again with our array tool. Okay, make sure it's on measure. Let's use the same measurement that we were using before, 28 inches or 2'4". I like that. It doesn't look terrible, but look what happens. We're falling short. Now, it's not the end of the world, because it's falling short back here. They're going to have to cut it back here. It's going to fall short on the 45 corner, but that's going to be covered up with brick. So nobody's ever going to see this small little piece essentially a 3/4 inch chunk that's missing out of the back because brick is going to be setting on this leading edge. So for the most part, that still works. And if it works there, it'll most certainly work here and on the rest of it as well. So let's go ahead and keep that piece. We could always grow. We could always grow it a little bit, but then we would make these pieces shorter. So let's just keep it like that. It'll work out. Let's go ahead and proceed. Four and 3/8. Let's grab our array tool. I'm sorry, that is not drawn properly. And neither is that. You'll see yourself making mistakes sometimes, especially around this time of the day when it's only natural for somebody to be tired. There we go. Okay. Oops, I did it again, see? Plus the weird angles when you're changing angles and so forth. It's also confusing for the mind. All right. So let's go ahead and change this to 28 inches. And that works out the same way. Okay. Let's go ahead and fix what we messed up here and here. That is definitely messed up. All right, let's go ahead and draw our line. 4 and 5/8. Ooh, what happened there? Array. Grab our long line. Measure 28 inches. Okay. Missing a little bit back here, but that's perfectly all right because they're going to cut it up here and you'll have a little bit missing off the back, but nobody will ever see it. Okay. Now, let's go ahead and now that we're proceeding here, I'm going to go ahead and explode these lines. And that way I can get rid of these additional extra lines that we had to add in there just for drawing purposes, the control line. And you do have to explode them because if you see when you're using the array tool, they're all connected, they're all one item. So in order to be able to delete one, you have to explode that. Otherwise, you'll end up deleting all the lines that you just drew. Okay, select one, explode. You can come back and delete that crazy line right there. Same thing here. Oops, what happened? Sure, yeah. Same thing here. We always want to delete the items that we don't need. Delete that, or explode it. Delete that. Delete that. Now it looks like that last line that I drew was a little bit too big for some reason. No big deal. We can trim it. We always want to trim stuff off and make things look good. Delete lines that we don't need so we're not confused later. Go ahead and add that corner. Check this dimension. Yep, 2 foot. 4. Yep. So we'll be missing a little bit. We'll be missing 3/4 of an inch off the back of that cut, but it's no big deal. Nothing that a mason can't figure out on site. Okay. Same thing here with this corner. This is going to be a fabricated corner, or a fabricated special piece, shall I say. Let's go ahead and add in our little detail lines. Some of the things that an architect will appreciate. I certainly appreciate it. Just trying to add a little bit more depth and detail to what it is that we're trying to communicate, not only to our third-party viewers, but to our shop people as well. Oops. Okay, looks like we've got all those lines added in for the most part. Adding detail can probably be the most tedious part of the job. But no doubt is it important. One of these days, AI is going to take over all of this. You'll have an architect do one detail, and then AI is going to take over and just copy what the architect did the first time around. Deep learning AI is going to take over everybody's jobs. And it's going to be twice as fast or 10 times as fast as a normal person. Okay. Let's proceed. All right, let's proceed with these spaces here. For the most part, they're very, very similar to these spaces. I'm going to double check this dimension here because I'm wondering why these dimensions are the same and that one's different. I'll go back to the drawing here. So this dimension is 8'4" 3/4. 8'4" 3/4. Okay. This dimension is supposed to also be 8'4" 3/4. So that is not a correct dimension. So we will have to correct that by using the stretch tool. So we don't want to mess with these, so we're just going to select this one. We want to reduce that by what, 3/4 of an inch? So when we use our stretch tool, if you're new to it, you want to select down through the middle of the object that you want to stretch. Make sure you select everything down the line. Otherwise, it'll mess with that too. It'll mess with the next one in sync. So all the way down, make sure it's all selected. Now when you right click to release your cruiser, you're gonna just back up a little bit, left click. Oops, did I hit the wrong one? I think Using scale, I'm sorry, stretch. Okay, stretch through the center. There we go. All right, what did we say? 3/4 of an inch. So we want to drag it in the direction that we want to stretch it. All right, stretching in, stretching out. So drag it in the inwards direction because it's too big. 0.75. Hit enter, and there you go. Your dimension was automatically corrected, and well, there you have it. You know what? I take that back. We need to go back and do that again because we already exploded these lines. We're going to have to stretch it through this last item to make it accurate. Okay? That way we're only shrinking the last item. There you go. That way that last piece is the one that gets shrunk, not that one. All right. Let's go ahead and add these lines. Sorry, I'm 4 3/8. Okay, that's the line. So 4 3/8. Grab our array tool. Click on that back line. Measure 28 inches. And we're good as gold. That last piece will be cut. And it doesn't look terrible. All right, proceeding. Uh-oh. What happened here? All the lines got shifted. Huh. That's kind of strange. I don't even want to dig into that problem. So let's not dig into that. I'd have to completely dissect this side to figure out what was going on there. I would think maybe, let's see, this 4 inches. No, no. Huh, it's very strange. Interesting indeed. Okay, well, we'll leave it like that and we'll come back and fix it. Let's try it again. 1 3/8. Oh, I know. Because my brain is tired and I did it backwards, that's why. It's okay. Array, select that. Sorry about that. 2'8". Next one in line. Apparently same thing happened there. I'm getting a little tired here, guys. Oh, that'll happen with my health condition. 4 3/8, not 5/8. Right. Oh, select our long one. 28 inches. All right. Let's go ahead and explode these. That way we can delete the lines that we don't need. We can fix these. Trim, 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 delete. This one's okay. Explode, delete. Trim. Oops, I apologize. Explode first, then trim. There we go. Now we're going to use the extend tool. And we're going to extend all of these lines to touch this line where it should have been. Extend, select the line that you want it to extend to, right click to execute, and then select your lines. Like magic, it closes the gap. Okay, delete the ones we don't need. Explode. Delete the ones we don't need. Okay. Looks like we have all of our lines drawn. Now, the next step is to get all of these lines on the other side. What fun. Well, the good thing is that there's a tool called Mirror. Now, the easiest way to use this tool is to have a halfway line. Something that you can click that is halfway in between. Well, the best thing that I can do is show you. So the easiest way to use this tool, in my opinion, is to get yourself a line. My brain is tired. I wish I could explain it to you another way, but just make sure it's evenly placed in between your originating point and the point where you want your lines or your mirrored objects to be. Okay, so I placed it here. It's an even line between the inside of the stone. Okay, and what I mean by center point is when you select that line, you see how it has 3 dots? This is your center zone. Okay, so what you can do is you can click on mirror, or you can type in the command. You want to select these lines, the ones that we took so much time and effort drawing in there. Okay, you're going to select all those lines. All right, now that we have all those lines selected, you're going to right click. You're going to go, it's going to specify, it's telling you right here in the command line, specify the first point of mirror line. So we're going to go over here and we're going to select the midpoint of the line that we drew in between this column. It's going to serve as the midpoint or the mirror line. So we're going to click on that. Now we're just going to rotate the cruiser. See how, I don't know if you can see it on the video, but you see how if we rotate off of center line, those lines that we have on one side get mirrored over to the other side. So now that you see those lines in place and mirrored where you want them, you can left click. Now it's going to ask you erase source objects, and you're going to select no. And there you have it. Now you have an exact mirror image of the lines that we had on the other side. Now you can delete that line. And you're going to want to do the same thing on this side. Select mirror, select lines. Be very careful to only select the lines that you want to mirror. Okay, now that we're done doing that, let's go back here and right click, and then select the center midpoint line of the line that we just added in between the column. Rotate our cruiser, right click to lock it in, click on no, because we don't want to erase our originating points. Now we can delete that line. All right, same thing here. I'm going to go ahead and, oops, draw a line so that we have a center point to mirror off of. Click on the mirror. Very, very careful to only select the lines that we want to mirror, nothing else. Now we will click on the center line, rotate, make sure our lines are where they want, left click, click on no. Delete that line. All right. Look at what we've created. We have created a layout of water table. This is going to serve as an installation drawing and a fabrication drawing for the most part. We still have this section here to finish, but you get the idea on how to finish it based on what we've done here. So what we're going to do here, we're going to go ahead and add dimensions to all of this. Okay. Basically the same way we added dimensions here, but we've got to select a dimension that's going to do, it's got to be just the right size, not too big, not too small. So when we lay it out on paper and print it, the dimension can be seen. So that's kind of tricky sometimes, especially when you're printing it on smaller sizes, smaller pieces of paper. You can't zoom into them like you can on a computer. So it's a little tricky. This dimension, probably gonna lay it out as a 32, maybe even a 48. Now see, 48 is probably ideal, but you can see where it gets a little too big. Let's see. Where did 48 go? There we go. Let's see. Yeah, 48 probably work. All right. So what we're going to do is we're just going to put dimensions on all of these lines. And it's important to put a dimension here on these inside cut pieces. They're going to be full-size pieces. As you can see, when you put a dimension on it, it's going to be 2'6". But measuring it from this side, it's only 2'1 5/8". So we want to make sure that they understand that this is a full-size piece. And sometimes the only way to do that is to kind of jumble up your measurements, and it's not always the best thing to do. But we want to get our point across that this is a full-size piece of stone. And sometimes that's the only way to do it. I'll go ahead and drag these up. Now, I also want you to take note that if this was a super detailed job that just required the utmost detail, we would also be drawing these pieces of stone with joints or joint lines. And that definitely gets a lot more detailed, but on this particular job, it's not really necessary. Again, every job is unique, and you really need to kind of follow up with me on that. But because this is a cut to fit job, we're going to be manufacturing one standard piece, which is 2'6". This will be, this is sufficient. Oh, goodness. I just now noticed that. 2'6", 2'4". Did I forget to change one? I think I might have forgotten to change one of our details. So I left these at 2'6", interestingly enough. So we're going to have to do this again, which is not that big of a deal. It's 2'4". Okay, perfect. Now we can explode it. Delete our unnecessary line. We're going to mirror our lines. All right, and there we have it. Okay, now we'll go ahead and add our dimension lines back in, like magic. 2'4", and our last piece will be field cut. It'll be 2'4", but they're going to cut it to that dimension. Okay, and basically now we have the very boring task of just adding in all of these dimensions. Once we add all the dimensions in, we can finish detailing that, adding the dimensions there. But I'll go ahead and continue now that we've already done the layout, we have the joints drawn in there, you've learned how to use the array tool, and more or less got an idea of how the pieces are supposed to be laid out, how we're doing this drawing, this particular drawing. I'll go ahead and finish this up and then start a new video tomorrow on how we do piece counts and how we're going to format this drawing and lay it out on a piece of paper. So we've already come to the conclusion that we're going to go ahead and manufacture a standard straight piece, which is going to be 2'4" long. So we're going to go ahead and draw that now using our square or rectangle tool. I'm going to hover over that so that we get our snap lines, drag it over, dimensions. It is 28 inches long by 5 5/8 inches tall. I'm going to click enter. There we have our piece with dimensions. We put our dimension on there. Actually, we're going to shrink that down, whatever size that is. Actually, that's probably dim 16. I'm going to draw that little, we're going to draw another line here. We're going to explode this box. We're going to use our offset, and we're going to offset the top by 3/4 of an inch so that we capture in the imagination of everybody that there's a 3/4 of an inch chamfer on the front edge of the stone, because that's what we're looking at, is the front of the stone if we were standing in front of it looking at it. So that right there is the standard piece that we're going to be making here, with the exception of these pieces and the special pieces that we have to make for the columns. Okay, well, until tomorrow, we can make, we'll meet back up here tomorrow and start some new videos on layout and how to finish this drawing up. Y'all have a good evening.